let's do the 19th one. This is the limit x multiplied by secant x where x approaches 0. Okay, now when you apply 0 to this function, you get 0 upon secant 0. Secant 0 is 1, so 0 upon anything is 0. It is 0. Okay, now let's try to change this and see if we get any other answer. Okay, now secant x can be written as 1 by cos. You know secant x is secant theta is equal to 1 by cos theta. Okay, so reciprocal. So let's try change this. That is limit x multiplied by 1 by cos x. Okay, x tends to 0. Now again, when we apply the value of x, it becomes 0 multiplied by 1 by cos 0. Cos 0 degree is 1, so it becomes 0 multiplied by 1 by 1, which is 0 by 1, again 0. But this is not indeterminate form. Okay, 0 upon 0 is indeterminate, so this is valid answer. Even if you directly put the value of x in this, you get 0, same answer. Okay, so this is the answer. That's it. Now let's do the 20th one. Okay, now limit of this function where x approaching 0. Now when we apply the value of 0 to this sine 0, and this also becomes 0, this is 0, this is 0, so it becomes 0 upon 0, indeterminate form. So let's change this. Okay, now again they have given conditions a comma b. A should not be 0, a plus b should not be 0. Okay, now you see sine ax, here sine bx. Now let's try to convert this into sine x upon x. Okay, limit x tends to 0, which is equal to 1. Okay, let's try to convert this, change this to this form, so we can use this theorem. Okay, so now this can be, now let's multiply, and so let's divide this numerator by ax so that we can get ax here, and denominator by bx so that we can get bx here. Okay, now limit sine ax plus bx upon ax. Now to balance this, we have to multiply again by ax. Okay, whole divided by ax plus sine bx upon bx. Okay, this is bx, so we have to divide by bx, and to balance again multiply by bx. Limit x tends to 0. Now you see we can cancel out this x and x. Now a and b becomes constant values, so constants can be brought out of limit. Okay, so it can be written as a upon b limit x tends to 0. Now see, this ax can be split to both of this, given to both of this. Okay, it can be written as sine ax upon ax plus bx upon ax. Okay, whole divided by, same thing here, limit, and this limit also can be split to both the numerator and denominator. Okay, limit, so we have theorems for that. Okay, limit x approaches 0. Now this becomes ax upon bx plus sine bx upon bx. Okay, now let's take the limits and give it to both of them. Let's split into inside. Okay, now we have a theorem for that also. That is limit x tends to a f of x plus g of x whole. Now these are two functions, like this, two functions. Okay, so we can split this as, which is equal to limit x tends to a f of x plus limit x tends to a g of x. Okay, in this way we can split the limit to both the functions. Okay, so that we are going to follow here. Now let's split this inside. It becomes limit x tends to 0 sine ax upon ax plus, now see, this get cancelled, x and x can be cancelled out. Here this also can be cancelled out. So now you have limit x tends to 0 b upon a whole divided by, now this one, limit x tends to 0 a upon b plus limit x tends to 0 sine bx upon bx, okay, whole divided by this, sorry, multiplied by this a by b. Now you see this becomes 1 by the theorem. According to this theorem, this becomes 1 and this also becomes 1. Now constant cannot apply the value, so constant remains constant, okay. So this now will be changed to a by b multiplied by, now this becomes 1, so 1 plus 1 plus this becomes b by a whole divided by, again this one a by b plus 1, this becomes 1, a by b plus 1, okay. Now taking the LCM for this and this, we get a by b, this becomes a plus b whole divided by, and this one becomes b a plus b, okay. Now again this can be written as, a by b multiplied a plus b by a, and this can be written into the multiplied as reciprocal b by a plus b, okay. Now you see a plus b and a plus b gets cancelled, b and b get cancelled, a and a get cancelled, so you have 1. So this is the answer.